Yeah. Hi guys, welcome to Binary Beast. So, as decided, we are again going to solve the Hackaerrank interview kit. So, let's start with the dynamic programming part. Uh, yeah. So today we are going to solve the Candies problem. It's I don't know why they have put it in the dynamic part, but the thing which I really liked in this program was the approach. That is, we do not have to follow a big O and square approach. There is a very nice and very smart approach to it. So let's see if you can figure this out or not. So it took me around 40 minutes to figure it out, but I can say from my experience that this pattern or this approach is very beneficial for all the further codes, because I know one of the like same similar type of program was also asked in the Google Kickstart in I think G round. I don't know much, but this type of question I was familiar with it, so I was able to solve it in about 25 or 30 minutes. I don't know. Okay, so let's start with it. The problem name is Candies. Let me just explain you what it is. You can read it by the way, but I've already read it, so I can just explain you in a more nice way. Okay, so we have been given an array. Let's say this is we have been given this array. So these are the marks of a student. Okay, so these are the marks. So let's say student 1 has scored 4 mark, student 2 has scored 6 mark, then again a 4, then a 5, 6 and 2. Okay, so now what we want to do is that we are a teacher. Okay, so I want to give candies. Okay, what I am a little bit partial. So what I'll do is that I'm a miser as well. So what I do, I will try to buy minimum candies. Okay, but in such a manner that those who have got like higher marks will get more candies. Okay, so let's say I'm starting with the 4. So this student is getting 1 candy. Okay, then the 6. Okay, now there is a rule that Alice wants to give at least 1 candy to each child. If 2 child are sitting next to each other, the one with the higher rating gets more candies. And Alice wants to minimize the total of candies she must buy. So what it implies is that 6 is sitting next to 4. Okay, that means the student 2 is sitting next to student 4, and the marks is also greater. So the candy which the second student will be getting will be more than the candies than the first student. Why? Because his marks is 6, which is greater than 4. So he will be given 2 candies. Okay, so now the third student is getting 4 marks. So it's less than the previous one, which is the 6. Okay, so what I'll be trying to do is that I will reduce the amount of candy, so I'll give him 1 candy. Okay, because it should be less than the adjacent one. Now let's say 5. Now 5 is greater than 4, so what I'll try to do is I'll increase the number, so I'll give him 2 candies. Okay, then now there is 6 means the 2. Now the marks are greater, so he'll get more candies compared to the adjacent one. So if he's getting 2 candies and he is having less marks than me, and if I have more marks, then I deserve more candies. So I'll get 3 candies. Now he's like me. I also do not get more marks. So he got 2 marks, which is less than 6. So what teacher will try to do is that, as teacher is also like slightly miser and do not want to spend much amount on candies, he will not give him 2 candies, but he will give me least amount. So he will give him 1 candy. Why? Because it's clearly mentioned that Alice wants to minimize the total number of candies. Okay, so he is being given 1 candy. The summation of all this is 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 2 6, 6 plus 3 9, and then it's 10. So the summation is 10 candies. Seems simple, but it's not. Okay, so yeah, it's not. Literally, it's not. This was the example in which all was going in a smooth manner. But let's take a little bit complex example. Okay, I have made a test case. It states that there are 6 students. Okay, so there is 4, there is 3, there is 1, 6, 4, and 3. Okay, now these are the marks. Now let's assume that the first student is getting 1 candy. Okay, let me just properly format it so that it's easier to understand. Okay, nice. Okay, so I have given him 1 candy. Okay, let's start with 1. Okay, so he is bringing 1 candy. Now the second student is getting 3 marks, which is less than 4. So what I'm supposed to do is that I have to give him 1 candy less. Okay, but now there is already 1, So what I'll do, I'll have to increment this 1 again to 2, and then I have to give him 1 candy. But now there's again a problem. This one is only scored 1 mark. But how can we reduce 1 to 0? I mean, it's already given that at least Alice wants to give at least 1 candy to each child. So how can I do this? So I cannot, just give him 0 candies. I have to give him 1. For that, I have to increment this to 2 and this to 3. Now let's say 6. Now he's a topper. So in this case, if the number is increasing, I do not have to worry a thing. I'll just increment whichever is the adjacent. So it's 1. So I'll just increment it. Now it's 2. Okay. So now it's 4. Now 4 is less than 6. So if he's getting 6 marks and he's getting 2 candies, then I'm 4. Like I have got 4 marks. So I'm less than 6. So I cannot get more candies than him. So I'm getting 1 candy. That's it. Now it's 3. Oh, now because the adjacent one who was having more marks was only getting 1 candy. Now how can I get 0 candies? So what I'll do is that I'll just make it 2, I'll make it 3, and then I'll make it 1. And remember one thing, guys, we cannot, now we have to stop here because we cannot make this as 4 because 1 is less than 6. Okay, so now this is the complexity. In this example, it was all smooth. We all thought, including me, I also thought this is a very simple program. It's a cakewalk. We can easily complete this. But no, there was a trend which we need to observe. We have to first judge the highest amount of candies a student can get, so that we can observe that pattern and we can initialize that array with that element. Now the approach. Okay, so now this is the time where you need to stop this video and think on your own, which is the approach that you would follow. Okay, so just pause it. Okay, so now I'm starting with the solution. As I mentioned in my previous videos as well, please do not focus on solution, focus on the how good are you in your approach. Okay, let's start with the solution. So what I had thought of it, maintain 2 arrays. Okay, I am maintaining 2 arrays. That is, in this case, if we take this, I'm doing this solution. Let's say, okay, just take it. I don't know. This is our solution. We have to match it. Okay, so now what we have is 4, 3, 1, 6, 4, and 3. Okay, this is the same array which I have written here. This is the same array. I'm writing it again. Okay, now I'm maintaining 2 arrays, the left array and the right array. Okay, now what we're trying to do is that first I will go from left to right, and then this one I will go from right to left, and then I will have a maximum. Okay, now I'll explain you what it is. First, what we will try to do is that we will start from 4 and we will go from 4 to 3. Okay, so now as usual we are starting with 1. That's simple. Now 3. Now is 3 greater than 4? No, 3 is not greater than 4. So what I'll do is I just write 1 here. Now 1. Is 1 greater than 3? No, 1 is not greater than 3. I'll again write 1 here. Now 6. Is 6 greater than 1? Yes, 6 is greater than 1. So what I'll do is that I'll just increment. I'll just add 1 to the previous one. That is the entry of the previous. I'll just add 1 to it. So this becomes 2. Now 4. Is 4 like greater than 6? No, 4 is not. It's just 1. Because if it's not, then I have to just write 1. I do not have to think anything else. And if it's less than, what I need to do is that just add 1 to the previous element. That is, in this case also it's 1. So I have to write 1 only. Okay, now in the right array, what I need to do is I have to go from right to left. Okay, so what I'll try to do is that I'll first initialize this from the last element as 1. Then I have to move from 3 to 4. Now 4 is greater. So what I'll do is add 1 to the previous element. So now it becomes 2. Okay. So now 6. Now 6 is greater than 4. So I'll add 1 to this. Now it becomes 3. Okay. So now it's 1. Now 1 is less than 6. How can I add this? I have to just write 1. So I have written 1. Now it's 3. Now 3 is greater than 1. So I have to add 1 to this element. So now it becomes 2. I am not good in formatting and all this. Okay, so now it's like 4. Okay, so now 4 is greater than 3. So what I just need to do is that add 2 to the previous element. So it becomes 3. Okay, now is the main part. Now I have to just iterate. Now I have to just simultaneously zip the L and R array and try to find the maximum from it. So let's say from 1 and 3, which is the max? It's 3, right? So 3 plus now 1 and 2, which is the max? It's now 1 and 2. 2 is the max. So 2 plus 1 and 1. 1 is the max. Now 2 and 3. 2 and 3, which is the maximum? Okay, I like I'm using the free version of this, so it stops after 10 minutes. I don't know. If you support me, I'll buy a premium version. But for that, please like and subscribe. Okay, so let's move on. Okay, so now it's 2 and 3, so we have chosen 3. Okay, so now it's 1 and 2, we have the maximum is 2, so I took 2, and then from 1 and 1 I took the maximum, which is the 1, and then I will get my answer, that is 3 plus 2 5 plus 1 6 plus 3 9 10 11 and 12. So my answer is 12. Okay, this is the logic which we are going to follow in our code. So let's just code it. The code is going to be, I think, very simple. I think, at least I'll be just making one more thing. Let's just name it, what should I name it? Hackaerrank. Okay, let's just start. All the basic stuff. Okay, so now what's the input format? Let me just look at it. What's the input format? I think so. Okay, so it's n and all the numbers are preceding, that is the marks. Okay, so what I need to do is that I just maintain a long int and n, then c in n, then I'll just maintain an array. So long int arr of n, I'll just take the input from the user. Long int I is equal to 0, I is less than n, I plus plus, and c in arr of I. Okay, this was the basic stuff. I think you might be all aware of it. If you do not know this, please go to the basics. Okay, so let's start. As I just told, we will be maintaining two arrays, the left one and the right one. So, and the third one, but it's not an array typically, it will be a summation. So we don't want to waste any space. So I'll just form two arrays, the left one having the same size and the right one again having the same size. Okay, so now let's just iterate from left to right. We can, like, I mean, we can in the one loop only we can iterate from left to right as well as right to left, but for better understanding I'm just iterating for both the times. Okay, you can optimize this. Obviously I will be starting from I is equal to 0, I is less than n, I plus plus, and there we go. Okay, but before that, as I just told, that the first element of the L should be initialized to 1, so I'll be just making it left of 0 is equal to 1. Okay, now as I have already initialized 0, I'll be starting with 1. Cool. Now what I need to do is that if the left element is like if my like 4 and 3, so the 3 element is less than, right? So what I'll try to do in here is that if my left of I is let's say less than, okay, if my left of I is less than left of not left, I think, because arr, this is my arr array. Okay, so I'm iterating, I'm comparing this array, so it becomes arr. Sorry, my bad. Okay, so arr of I, if my arr of I is less than if arr of I minus 1, then what I need to do is that left of I is equal to 1. Why? Because arr of I 3. Now is 3 less than I minus 1 4? Yes. So what I need to do is that left of I is equal to 1. Else what I need to do is that left of I is equal to left of I minus 1 plus 1. That is the left of I minus 1 plus 1. Cool. Now this was the left. Now let's just initialize again with the right. But in the right one, I do not have to put 0 here. I have to put n minus 1. Why? Because you are starting from the rightmost element. Okay. So now let's just reverse the whole loop. So it becomes, let me just convert this into long int. Okay, I don't know, because it's just that the range is of 10 raised to power 5. That's it, nothing special. Long I int I is equal to, I'm starting with n minus 2. Okay, n minus 2, I will be greater than equal to 0 and I minus minus. Okay, now what I need to do is that if I'm iterating from right to left, okay, then what I need to find is that if my this element, which is my ith element, is greater than my I minus I plus 1 element or not. Okay, so what I'll be trying to do is that if my arr of I is greater than, okay, now let's just to make it uniform, I'm taking it less than. If because here I'm taking less than, so I'll be taking here less than. It's just for better, so that you can understand better. That's why if arr of I is less than arr of I plus 1, then I have to do something, or else I have to do something. Okay, now let's just know what it is. If ARR I, that means we are here, by the way, because we are starting with n minus 2. If ARR of ni is less than ARR I plus 1, that is 4. Okay, if my 4, in this case we are greater, so what we are doing is that we are adding. Okay, so I'm writing the else condition. Right of I is equal to right of I plus 1 plus 1. Why? Because if my ARR of I is greater than ARR of I plus 1, then what I need to do is that right of I plus 1 is equal to my right of I. That's what you get. And in this condition, it's simple. Right of I is equal to 1. That's it. Now, if all things go well, I think we are very close to our answer. I'm just maintaining a long int answer is equal to 0. I'll be just iterating through as both the arrays are of the same length. We do not have to take separate cases or so. Now, as I mentioned in the previous video, we do not have to write code for the maximum to find the maximum, because there is already a predefined thing of algorithm. Okay, so that's it. I think we are done. Answer is equal to maximum of either it is right of I or it is left of I. See out answer. Let's just hope there's no error. Please, yes. Okay. So let's just run this one. So it's there are 6 elements. So I'm writing 6. Now there is 4 3 1 6 4 3. 4 3 1 6 4 3. I'm getting 10, so that's the wrong answer, by the way, because what we got is answer should be 12. Okay, so let me just figure it out what's the thing, and then what I'll do is that I'll just print my both the arrays, that is the left and right, so we can get a clear picture of where we were wrong. Okay, so for int I is equal to 0, I is less than n, I plus plus, see out left of I, and what I need to do in this case is that for just better readability, is equal to 0, I plus plus right of I. Okay, I'm just writing and then so that we can clearly separate them. 6 4 3 1 6 4 3 4 3 1 6 4 3. Okay, see, what we got is we got 1 1 2 1 1, we got 1 1 1 2 1 1, it's right. And for here what I got is 3 2 1. Okay, so now here's the thing, we are not getting 3 here, because what I think is that we are getting 3, we are getting 2, we are getting 1, but here it should be not 2 1 0. See, to 0 we cannot get 0, so that's the thing. Let's see what we have done wrong. Definitely we have done something wrong. Okay, so let's just figure it out. So look, so now I have given like right of n minus 1 is equal to 0. Oh shit, it should not 0, it should be 1. How can I make this mistake? So let's just compile it again. Sorry for the one who are following from me, like following this code from beginning. Let's just see, 6 4 3 1 6 4 3. So it's 4 3 1 6 6 4 3, and there you go, answer is 12. Let me just remove all the printed stuff and let's see. Okay, Control A, Control C. We are going to Hackaerrank, and there we are submitting this code again. Let's just run for all the sample cases whether it's working fine or not. Okay, we are failing one, I don't know why. Okay, so it's 3 and it's 1 2 2. My output is 6, the output should be 4. Okay, so I don't know what it is, so let me just run it in my compiler and then we can figure it out fast. See, we have what we try to do is that 3 and 1 2 2 3 1 2 2. Okay, so now what we got is that it's 1, it's 2. Okay, see, this is one of the special cases where both the students have got equal marks. So what we need to do in that case, when both the students have equal mark, it's not that the second one should get more candies. We can obviously make this 1. Okay, I have to make this video fast. It's already about 20 minutes. Okay, so but the debugging phase is taking too long. Okay, so what I was trying to say is that there are means the two students have got equal number of candies, but what we can do in this case is that instead of assigning two candies to him and then three candies to him, what we can do is, let's just come here, and in this space if I write equal to, and here also if I write equal to, and let's just compare it again. What was the test case? I forgot, by the way. 3 1 2 2 3 1 2 2. Now we are getting right. Okay, so let me just remove all the things. This was thing, right? No, this was not. I was about to delete the code. Okay, now it's cool. Copy. I'm getting here. Paste. Let's hope for the best. Okay, we are passing sample test cases. Let's just submit the code and see whether we are in right direction or not. Okay, okay, you have passed. Okay, so let me just tell you the last thing which we did, because I know that some of you may be confused in it. I don't know, fast, I think. It was the sample code was that if there are three students and one is getting 1 mark, 2 mark, and 2 mark. Okay, so what our previous code was doing is that he was like the code was assigning one candy to him, two candy to him, and three candy to him. But in the code it was given that if the two students are having same marks, we do not need to maintain the incrementing order. Okay, we there were two options for us. Either we could give him 1 2 and 3, or we could give him one for him, two for him, and then again one for him. It would be valid, and that's where the cost will be minimized, and we were specifically asked to minimize the cost. So that's what we were doing, and that's what I had done. Okay, so that's it, guys. This code is done. I will give the description of the code as well as the solution in the description, and if you like it, support me. Have a great day. Bye.